Factor difference of squares. In this, we can do factoring a couple of times. Let's see how to factor these difference of squares. Here we have x to the power of 4 minus 1, then we have x to the power of 8 minus 81, and some big numbers, 625 x to the power of 4 minus 256. Now let me show you the second one first. X to the power of 8 minus 81. We can write this as difference of squares. We could write this as x to the power of 4 whole square minus 9 square, right? Now 9 square is 81 and x to the power of 4 whole square is x to the power of 8. In fact, we have difference of squares here. So we can factor using the formula, which is x to the power of 4 plus 9 times x to the power of 4 minus 9. Now you can see that x to the power of 4 is actually x square whole square, correct? Let me show you. X to the power of 4 can be written as x square whole square, and 9 can be written as 3 square. Well, this is plus, so we cannot factor this one, but we can factor the other one, which is difference, where we have x square whole square minus 3 square. This factor, which is the second one, can be factored further. So we can write this as x to the power of 4 plus 9 times x square plus 3 times x square minus 3. Remember, factoring is completed only after you reach a stage that there are no more common factors. Do you see that? So here we have x squared minus 3 as the last factor. At times it could be written in the form of x to the power of 4 plus 9 times x squared plus 3 times, this could be factored as x plus square root 3 times x minus square root 3. So, at times we can always square root this. Now square root 3 square is 3. So it becomes a difference of square. Correct? So that is actually the last stage of this factoring. Okay. Now let me show you this last one, which seems to be more complicated. We have 625 x to the power of 4 minus 256. Now, can they be written as perfect squares? So you can do square root of 625. So if you use calculator and do square root of 625, what do you get? 625 square root gives us 25, right? So we can write this as 25, and we can write x square, and now a perfect square like this. So 25x square whole square is same as 625x to the power of 4. Similarly, you can find what is square root of 256. It is 16. So 16 square is 256. Now if we square root and get these numbers, then we have difference of squares. So finding square root is a good technique. Now we can factor them as difference of squares. So I can write them as 25x square plus 16 times 25x square minus 16. Now 25x square minus 16 can further be factored. Since 25 square root is 5 and square root of 16 is 4, correct? So we'll refactor it and we can get 25x square plus 16. Remember, if it's plus, then we cannot factor. Only difference can be factored. So we get here 5x plus 4 times 5x minus 4. So that is how we can factor binomials where the exponents are higher, right? Higher even, you can say. Then we can factor like these, right? Now it could be odd also at times. For example, I'll give you one which you could try, which is x to the power of 6 minus 1. right? So we could write this as x cube whole square, right? So it becomes even ultimately, but we'll do difference of cubes later. Okay, we'll leave it for the time being. The first one is kind of simpler. I should have started with that instead of getting into these complicated issues. Let's say x to the power of 4 minus 1, but I think now you can do it. It could be written as x squared plus 1 times x squared minus 1. Why x squared? Since x to the power of 4 is x squared whole square, and then we have 1 as 1 square, correct? Now x squared minus 1 can be further factored. So we can write this as x squared plus 1 times x plus 1 times x minus 1, right? So that is how we can factor these binomials with higher even degrees. Okay? I hope that helps. Thank you and all the best.